In this video, simply I'm going to show you how to set up Kubernetes to run a Flask application on two different nodes, so that if one fails, the other takes over and keeps the app running. One important thing I'll demonstrate in this video is the core functionality of Kubernetes and how it works in practice. Before diving into the actual setup, let's talk a little bit about Kubernetes and the overall workflow. There are many benefits to using container orchestration systems like Kubernetes, but one of the most important is high availability and load balancing. Imagine a website running on a single server. If that server crashes for any reason, your site goes down. One solution is to run a duplicate instance of the app on a separate server and switch to it when the first one fails. However, managing this setup manually is difficult. When using Docker to run applications, Kubernetes makes it easy to run multiple replicas of the same containerized app across different servers and automatically restart or reschedule them if one fails. Here's the big picture of what we'll do in this video. On the local machine, in my case macOS, we'll develop a simple Flask app and then containerize it with Docker. To make it usable in Kubernetes, we'll push the Docker image to the cloud. One option is Azure Container Registry or ACR. To run Kubernetes, we can either set up it manually on our own servers or use managed cloud service like Azure Kubernetes Service or AKS. Setting it up manually can be complex, so in this video I'll use AKS. So let's dive into the code and the configurations. In this video I'm going to use some terminal commands to do the actual job. You can do the same thing through the admin panel, but it's much easier to do it through terminal. So here in this article, a simple example to show how Kubernetes works in practice and deploy a Flask app running on AKS, I have all the commands you need to run your application on Kubernetes. So if you want to just copy and paste the commands from here, go ahead and do that. I'll put the link to this article in the description of this video. Let's start everything by checking if we have Python already installed or not. One simple way to see if we have Python already installed or not, we can just check the version, Python dash version. So we don't have Python, but sometimes it's because Python 3, we need to also check that as well. So we do have Python 3 installed on our machine. So if you don't have it, just go ahead and install it. It's really easy. You just need to take a look at the website. I always recommend that you install all your modules and packages in your Python environment. So let's create a Python environment. First of all, we need to go to the directory we want. So I'm going to go to, and here I want to create a new directory. I'm going to call it Flask AKS. And here I'm going to create a whole new environment using Python 3-env, using env actually here. I'm going to call it Flask env. You can call it whatever you want. There is a typo. And now we need to activate it. Flask env bin activate. With that we can activate the environment and you can see the name here. So now whatever we install, it's going to be installed in this environment. The only module we need here is Flask, pip install Flask. Now we have Flask. If I say pip freeze, we can see the list of all the modules. So these are installed along with Flask. We need to create a requirement file, so when we want to use Docker, it can use that requirements, the txt, to run the application. So simply I can say nano requirements.txt and I'll put Flask here. Save it. Now it's time to write the actual code. Simply I can say nano app py, and here I'm gonna have a really simple application, so I'm just gonna copy it from the article I showed you here. So you just need to copy this and paste it over here. So let me explain it, what it does. So first of all, we import Flask from Flask. We define an app of Flask. This is how it works. It's based on the documentation. You need to add an app route. So basically with this, we set a URL for the path we want. We say that, for instance, for the home page, we want to have this function or this text basically. So it's going to return when we go to the main URL of the website. It's simply going to return this text. It's not even an HTML page. It's just a simple text. And it's quite enough for what we're going to do. And in the end, we just need to run the application on host, on localhost, and port 5000. That's all we need to do. So if I try to run this, python app.py, so it says that port 5000 is occupied by another program. That's fine. We can go to app and change the port number. So for instance, 5001. We try again. We just need to allow it. And now we have our application running on this port on localhost. As you can see, we get this simple message. Now, because I'm going to use port 5000 for the rest of configurations, I need to change that back to 5000. Let me clear the screen. Now it's time to create the Docker file, which is responsible for creating our Docker image. Again, simply I said nano Docker file. And here again, I'm gonna put a couple of lines of configuration. So let's get back to the article. And here, I just need to copy this and paste it over here. Let me explain some of these configurations here. So first of all, it says that it's using Python version 3, version Slim. Also, the working directory inside the image is app folder. Then with copy, we copy requirements from outside wall into the Docker. So basically just grab requirements.txt and copy it and paste it inside the Docker itself, inside the image itself, run pip install. Then it's going to run requirements.txt to install Flask inside the image with this command. Then we copy everything else like the actual code we created a few moments ago, copy it into the main directory of the project, which is app folder. And then in the end, when we have Flask installed and also we have the actual code inside image, we can simply run the application with python app.py. And we just need to save this. Now it's time to build and push the image to Azure Container Registry Service. And after that, we can start deploying into Kubernetes. But to do all these things, we need some tools on our local machine like Azure CLI and kubectl. So we just need to simply install them. It's really easy to install them. On Mac, we just need to use brew install Azure CLI. I should have already these tools installed on my computer. Let's try brew install kubectl as well. Now, for Linux and Windows, the commands differ slightly. You can find the right command with a little bit of search. Now, to make sure we have Azure CLI installed, we can just check the version. Is it or Oz-version? Yes, we do have it. And the next thing you need to do, you need to log in into your account. So Oz login. And here you just need to log in with your Microsoft Azure account. It says login successfully. And here select subscription and tenant. Here the only subscription I have is this one. So I simply just need to say 1. Now we can use Azure CLI easily. The very first thing we need to do, we need to create a resource group inside our Azure account so that we can do everything under that resource group. AZ group create -- name. I can call it my resource group -- location is US, for instance. Now we have the resource group there. Now we need to create the container registry. AZ ACR, or actually Azure Container Registry. Create. We need to add the resource we just created and the actual name for container registry. I'm gonna call it my container registry. I forgot to add something. We need to add basic here for the authentication. Basically here with adding basic, we're saying that we want to use basic options with our account. We don't need premium features. So the source name is not correct. What we can do, my C registry. We need to wait a couple of seconds for this. Now we have our container registry up there. We just need to log in into that AZACR login --name myc registry. Okay, login succeeded. To be able to push our Docker image to ACR, we need the address for that. So get the server address with this command: AZACR show --name myc registry --query login server output tsv. Okay, here is the actual address for my container registry. We're going to use this in a couple of places. As I said before, for these commands, you simply just need to grab it from this article over here. I'm going to put the link in the description, and here I have all the commands listed here, so you can just select it and copy it simply. So if you take a look at the workflow again, so here we created our Flask project, then we Dockerize it on our local machine. Then we're trying to push this Docker image into Azure Container Registry. So far, we've been trying to create our Azure Container Registry on Azure, and then we did the login. And now it's time to actually create the Docker image and then push it into container registry we have. So here's the next step. We first use docker build -t. If I paste it here, you just need to replace this ACR login server with the actual address we got from the last command. Copy and paste it here. And we're gonna name it Flask AKS latest. This is the label and this is the name for that Docker image. So you can call it whatever you want. Simple mistake. I'm gonna call it Flask AKS. So here says that building finished, failed to solve, failed to read Docker file, open Docker file, no such one. Okay, here I made a mistake. The name for Docker file should be like this. So Docker file. Actually, the file should be lowercase. So if I try the comments again, Flask AKS latest. Okay, now it's building the image. And now we just need to push it. Flask AKS. Okay, now let's make sure that we have our Docker image up there. So go to your Microsoft Azure dashboard. So here, when I click on View All Resources, when I come here, I can see my container registry here. If I click on that, so here, if I search for repositories or image, here I have Flask AKS, and here's the tag and all the other information. It shows that it worked fine. Now here we have our Docker image up there in Azure Container Registry. Now it's time to actually set up the main job, which is Azure Kubernetes Service or AKS, and then run the application on that. Now we're getting close to the main part, which is creating the Kubernetes clusters with the number of nodes we want. Here's the main command to do that. So simply we just need to copy it. Let me explain it a bit here. With Azure CLI, we're using AKS or Azure Kubernetes Service. We want to create a new one. We define the resource group we already created. We choose the cluster name. We define the number of nodes we want to use. Here, I simply just want to go with 2 nodes, and node VM side just start B2S, generate SSH keys, attach ACR. Also here you can attach your container. Here it says attach ACR, my container registry. So let me copy paste it here, and the only thing I need to change here is this registry name. So I'm gonna call it my C registry. After a couple of minutes, it's finally done, and now we have our cluster up there. Now it's time to connect kubectl to Azure Kubernetes Service. kubectl is a command tool to talk to Kubernetes, but since we're using Kubernetes on Azure Cloud, first we need to connect them together with this command. Let me take a look at the article here. So this is the command. It's quite simple. AKS get credentials, define a resource group, and name the cluster you defined before. So it's going to be like this. Now kubectl has access to that. Now we should write the deployment configurations to instruct AKS how to operate. Simply create a file called flask_deployment.yaml including the following configurations. So it's a long list of configurations here. It seems a little bit scary, but trust me, it's not that scary. I'm going to explain the lines in a moment. Here we have two sections of deployment and service. So here's the deployment section and here's this service section. Deploying section is responsible to run your application basically on Kubernetes. So here we say application version, it's apps v1. You can say whatever you want. It's going to be deployment. The name of the application or the deployment is flask-app. Here we have some specifications like replicas. We want to have 2 pods basically for this deployment. So our cluster have 2 nodes, and also for the deployment we want to have 2 pods. So if you take a look at this diagram here, you can see that in Kubernetes, or basically Azure Kubernetes service, here we can have different nodes or different servers. So first of all, we can have different servers, and inside each server we can have different nodes. But here in our example, basically every server is gonna be a node. We have nodes, a pool of nodes basically, or a node pool here, and inside each node we're gonna have a couple of pods, as many pods as we want. Pod is basically the smallest part we can have in Kubernetes to run an application. So basically a pod contains our container, contains our Docker image or the Flask app we created, and we can have different pods. We can have another pod for something else. For instance, for the database, we can have another pod for other tools and services. Also, we can have 2 same pods of Flask app on single node or on single server. So here we created 2 different nodes on the cluster. So the cluster has 2 different nodes. Also, I'm going to instruct the deployment script the way that it creates 2 different pods. So it could have 2 pods in single node, or it can have 2 pods in different nodes. So here with affinity, we say pod affinity. Here we define that we want to have 2 pods on 2 different nodes we created before. Here we define the container we want to use. So as you can see, we need to replace this with our address, and here we need to use the actual name for the Docker image. Also, the container port here is 5000. So basically it says that the app inside a container listens on port 5000. So as you can see here, the application is on port 5000. So here we're instructing the container that it should listen to port 5000 to have access to the application. Also, here we have the service section, which is actually to have our application up and running with a public IP. So we can actually send traffic to the website. Otherwise, we're gonna have our clusters and running apps there, but there is no way to access that. Let me just simply copy it, clear it. I need the address again, so I use the same command again, acr show, and now I create Flask deployment YAML. Here simply I just paste it, and I need to change the name of the Docker image. It should be Flask AKS, and I need to change this with actual address. So let me copy it from here, paste it over here, just save it. Now the only thing it is left to do is use kubectl to apply the deployment to actually the Kubernetes on Azure Cloud. Flask deployment.yaml. Okay, deployment apps created, service Flask service created. Now let's check if we have pods there. So kubectl get pods -o wide. Okay, there is this error here. So basically we have our 2 pods there, but the problem is that there is something wrong and we can't have them running. So in this case, simply I can ask ChatGPT what to do about it. So I get this when running on AKS. So here it says that you can see the logs, kubectl logs. Let's check it. Okay, now I know what's going on here. So the problem is that the Docker image I created is built for macOS, but actually the server we have there is running on Linux. So we need to create the Docker image suitable for Linux. So simply I can use Docker buildx build to specify platform. So I can specify platform Linux MD64, and here I need to fix the name of the registry. My C registry, Azure CRIO Flask AKS latest. And now Docker push again. Whenever you face an error, simply you can just use ChatGPT to find the answer. But it's not really easy for ChatGPT or tools like this to do the whole setup for you. So you're responsible to put things together, but there's nothing stopping you from using ChatGPT to make it easier. Okay, now something bad happened. Let me try it again. Okay, now let's apply the deployment script again using kubectl apply-f Flask deployment. Nothing's changed. I can use kubectl rollout restore deployment Flask app. We can check the running pods with kubectl get pods. Come to terminal, just paste it here. You can see that we have 2 Flask app up and running here. Now the last thing we want to have is the IP address to access the website. So here simply we can get it with kubectl get svc flask-service, and here it's gonna give us external IP. If I just copy it and paste it here, and here it says hello from Flask on Azure AKS. Now let's take a look at the dashboard to see what's going on there. So here if I refresh, so here I have a bunch of things. I have my AKS cluster, I have my container registry, my resource group, but main thing we want to focus here is my cluster, my AKS cluster here. There are a lot of things here. Here you can see the node pools, and if I click on that, here I have one node pool containing 2 ready nodes. If I click on this, here it shows me basically 2 nodes here, and each node contains different kinds of pods. So here for instance we have a list of different pods. One main pod here is our Flask application, but we have other pods running on this node because to make the whole thing work we need different pieces put together to make it work. So everything else is coming from Azure itself. We didn't do anything about it. The only thing we deployed is Flask application. Now let's take a look back again at my AKS cluster. Here we can see services and addresses, and here you can see that we have Flask service. This is the service we configured to have the public access external IP. One thing you need to pay attention that if I try to use HTTPS here, it doesn't work because we haven't configured it for SSL. And to make it work with HTTPS, we need to have SSL certificate. But it's not for this video. Just make sure that whenever you want to have the access to the IP, you just need to use HTTP simply. So one thing I'm really interested in here is that basically if I take a look at the nodes again, one node pool. So here we have 2 running nodes. I want to make sure that it continues working when one of these nodes fails. That's the whole purpose of what we need Kubernetes, and we're using this orchestration tools. One solution is that simply I can select one of these and just hit delete. And that way I expect that it continues working. The other node takes over. Simply I can just delete it to see what happens. So my website is up and running. If I try to delete this node, okay, successfully deleted the nodes. So get back to cluster nodes. Here we have only 1 ready node. If we check the website again, you can see that still works, and that means that basically the other node takes over. So for any reason that if one node or one pod fails, just use the other nodes and pods. And actually you can configure it to scale automatically. Even if you have one node here, if there are a lot of traffics coming to your website, you can instruct it to just add more nodes to it if needed. But There are a lot of things you can do with Kubernetes and orchestration tools like AKS, but this was the main point for this video, so that you understand that why we are using tools like Kubernetes or AKS and what's the reason behind that. That's it. Thank you for watching this video. I hope you enjoyed this. Please don't forget to subscribe to the channel and also hit the like button if you enjoy the video. See you soon. Bye.